Hello, and this is video 17 for College Algebra. We're going to be looking at zeros of polynomials. So first of all, we're going to talk about the fundamental theorem of algebra. It sounds really big and fancy, but what it means is any polynomial of n degree, it has n number of zeros, and n has just to be greater than 0. So if I have a polynomial with a degree of 4, then I have 4 zeros. And that includes real and non-real. So first, for finding all the zeros, we're going to look at the graph to find 1 0. The graph should hopefully show us 1 0. And then with that, we are going to use synthetic division to find that all the other zeros and verify that it is a root. And remember, from long division, we know that it is a root if our remainder equals 0. And then from that answer that we get after dividing, then we can factor that, or we might have to use quadratic formula, or even sometimes we might have to use synthetic division again to get something that we can factor to find the remaining roots. So we're going to jump in here with an example. If you have a graphing calculator or using Desmos, you can plug it in, and we can look at the graph. So this is our graph. It looks like we have a 0 at 5. We can always check our table, and yes, we do have a 0 at 5. So we just need to find the remaining 3 roots, or the remaining 2 roots, so that we can find all zeros. So we're going to start. We have a 0 at 5, so we can divide by 5, and I think it's always easiest to use synthetic division. Remember, we write out our coefficients, and then we skip a space, draw our line, and drop down that first number. So 5 times 1 is 5. We add these together, and then we keep multiplying through. Now when we add our last 2 together, we get 0. So that does confirm that we do have a 0 at 5. So our remaining polynomial is x squared minus 10x plus 25. And we can go ahead and set that equal to 0 and solve. Now, we can factor this, what multiplies to 25 and adds to negative 10. That would be negative 5 and negative 5. So then we set each factor equal to 0 and solve. And so we can clearly see that we're going to have x equals 5 for our other 2 remaining roots. And we already know that we have x equals 5 as a root from looking at the graph. So here, we can look at the zeros. We can say our zeros are x equals 5 with a multiplicity of 3, which that makes sense because looking at our graph, it bends at that 0, which is what happens with a multiplicity of 3. All right, so our next example, we're going to do the exact same thing. We're going to first look at the graph to find our zeros. All right, so we can see our graph. It looks like there might be one at 2 and negative 1, but let's just double check. There is one at 2, so let's just go ahead and use 2 as our number that we're going to use to divide. You could also use -1, so we've actually found 2 zeros, and we need 2 more because this is an exponent of 4. But let's go ahead and use 2, and we can find the others using synthetic division. So remember, we drop down that first number. 2 times 1 is 2. Add those together is 1. 2 times 1 is 2 again. Add those together, we have 3. 2 times 3 is 6. Add those together and we get 3. And 6, and we get 0 as our remainder. So we translate this to our answer, x cubed plus x squared plus 3x plus 3. Now we have 4 terms, so we can solve using factor by grouping. So you group our first 2 together and our second 2 together. Now we can take out the GCF of our first group, which is x squared, and I'm left with x plus 1. The GCF of my second group is a positive 3, and I get x plus 1. And then from there, we regroup. These 2 binomials in parentheses, those need to match. If they don't match, then we probably did something wrong. So we've got x plus 1 and x squared plus 3. So now we put those equal to 0. All right, and so we get x equals -1, which we knew that would happen because we looked at our graph. And here we have x squared equals -3, and x equals plus or minus I square root of 3, because we're square rooting that negative. And then from our graph, we've got x equals 2. So here we've got all 4 of our answers. We've got -1, we've got I square root of 3, and negative I square root of 3, and then 2. All right, the last part of this is talking about conjugate pairs. So if we have a plus bi as a 0, then we also will have a minus bi as a 0. So here, find an equation that has zeros at -1, -1, and 3i. Well, I automatically know that I'm also going to have a 0 at -3i. So this is going to be a quartic function. So I like to start off with what I know. If I'm going to have a 0 at -1, my binomial is going to be x plus 1. So I've got another x plus 1. If I've got one at 3i, I know I'm going to have x minus 3i and x plus 3i. And so now we can simplify this. This could be your answer, but most of the time we need it in standard form. So I would go ahead and distribute your 2 polynomials individually. So this would become x squared plus 2x plus 1. And then distribute your second pair. And this simplifies to x squared plus 9. All right, and now we can multiply this all the way through. So it's a lot of distributing. So we would get x to the 4th plus 2x cubed plus x squared plus 9x squared plus 18x plus 9. So let's go ahead and simplify that all the way. X to the fourth, 2x cubed plus 10x squared plus 18x plus 9. So that is our final answer. You can check your work by plugging this in, this original equation into Desmos or your graphing calculator, and the second one in, our final answer, and double checking that it's the exact same graph. All right, this next one, if we know that there's a 0 at 3 plus 2i, then I know that there's also a 0 at 3 minus 2i. All right, and so we can look at our graph to find the remaining zero. So we've got x cubed so looking at our graph, looks like there is a 0 right at 3. Let's check our table. And yes, we've got a 0 at 3. So we can double check that by using our synthetic division. So I've got 1, -9, 31, and -39. So we drop this down. We've got 3, -6, -18, and 31. And hopefully you guys are getting better at synthetic division. I like it. It's kind of like a puzzle to me. So I've got 0 as my remainder. So that confirms that 3 is a 0. All right, so just remember, we have to have a remainder of 0 to know that it is a 0. And we'll go ahead and call that a root, so we stop saying 0 so much. So I know that my zeros are at x equals 3 plus 2i, x equals 3 minus 2i, and x equals 3. All right, so this was, we used synthetic division and our graphing calculators to find all roots. And remember that the fundamental theorem of algebra means the number, whatever the degree is, that's the number of zeros that we have.